talking today about volume problems again, and we're going to be still talking about volume of rectangular prisms. And one practical way of needing to
back a little bit.
What's that? Oh,
move it back a little bit.
And my computer back a little bit.
There you go.
A practical way of volume, remember what volume does is it tells you the space inside something. And I like that word Mrs. Nelson used yesterday, capacity. And one of the things we're going to do is we're going to find the volume or the capacity of an aquarium. So if we had an aquarium, one practical reason is I bought an aquarium, I want to know how much water it's going to take. How much water do I need, especially if I have to, in my aquarium, use special water, not water from the tap. I might have to buy deionized water for my fish or something, and I've got to know exactly how much water I need, so I don't buy too much or I don't buy not enough and I have to go back to the store. So the dimensions of our aquarium are...
You need one more line.
Oh, I do need one more line.
Yeah, you do. Sorry.
I missed you before.
As long as we're practicing.
Line as well. All right. There we go. All right. The dimensions of my aquarium is this is 24 1/4 of an inch. And this is 12 1/2 inches. And back here, going back here is 20 inches. Now I know how much water, and I'm going to find it, since my units are in inches, I'm going to find it in cubic inches, and then I'll have to convert it to gallons before I go to the store. But let's figure out what the volume is. So whenever I'm talking about volume is always the same initial formula, big B times height. Now the formula for big B, the area of one of the bases might change depending on your shape, but it's always, volume is always the area of the base shape times the height. And I just have to do a little thinking when I'm thinking there. So I have a choice to make. I just need to find what I'm going to be using for big B here. And I'm going to use this face here. I can choose any face that I want. I'm going to choose this face right here. Okay, so if I kind of looked at this and pretended like this was like an aquarium, just a smaller, I'm just going to be looking at this face here, and however many rectangles are stacked going back this way. So for big B, I'm going to just do a little work over here. For big B, I want to draw a picture of what my big B looks like. I'm putting it in red because that's the face I want to use. I want to just take a moment and draw it right back over here again. And I'll put the units on there, the dimensions on there, the two dimensions that I'm looking for that face, 24 1/4 inches and 12 1/2 inches. Okay, and so I'm going to use that to calculate my big B. Big B, I see it's a rectangle. I'm thinking it's length times width, but I really want to think about base times height. So I'm going to move that down here. Base, 24 1/4 inches times my height of this face, which is 12 1/2 inches. And I need to multiply those two numbers together. So I have got several choices to do. I could be working with decimals. I could do this problem, 24. I know 1/4 is 25 cents or 25 hundredths. And I know 12 wholes and half is 50, half of $1 is 50 cents or 5 tenths. I could even do 5 tenths. I could do this kind of problem and I could work that out and get my answer. I could work with fractions. So if I did that, I could take 24 1/4, 4 sets of 24. That would be 2 sets of 48. 2 48s would be what? Well, 2 45s would be 90. 96? Somebody chime in if I'm wrong. 96 plus one more makes 97. Okay,
And
so
I
like,
would just do 4 times 25 and subtract the 4. I'd just do 100 and then subtract 4 to get 96.
get 90. Oh, that's it. Yeah, that's a lot easier. That's a whole lot easier. And then one more makes 96 plus a double check. So thank goodness, because I went the hard way. So I'm glad we double checked it another way to know that makes sense. 12 times 2 is 24, and one more makes 25, and I have a 2 here. I can try to simplify a little bit over here. I can try 2 times 1. If I simplify, I get the factor of 2 times 1. Oops, except I wrote 2 there again. Because it was going
Would that be 25 or 24?
24 plus 1 more? 2 sets of 12 and 1 more? 24,
Okay,
25?
sorry.
No, that's okay. No, I'm glad. I was double checking, always double checking.
I got confused. I thought we were simplifying 96 over 4.
Oh, we could. That's actually even a better way. How many times would 4, can 4 go into 96? 2 times, yes. 2 times, so that's 8, 16, 24 times. So I could just simplify this whole thing to 24 over.
That's why I know that's wrong, Mrs. Brown, because that should be 97.
Should be 97. Yes, it should be 97.
Because I was looking at it at first, I was like, I think she simplified it, and then I missed the multiplication. It's hard from where we're seeing it to see if it's multiplication or
Is that better?
division. Yeah, that's good. But so I was a little confused. So it should, we forgot to add our 1 on our improper fraction. So
Okay,
it would be
so let's take that.
97.
97. I know it was seeming to be an easier problem when I
Yeah, I
looked.
was like, thank you. Sorry.
No. So that I could do, and it gets a little bit, I don't see any way I can really simplify. So I have to do 97 times 25 and then divide that by 4 times 2, which is 8, and I could do it. I just can't see an easy way to go down the line. But I could do it certainly that way. And if I wanted to check it on a calculator, which I do right now because it'll take me a little bit of time, but if I want to check it, 24 and a quarter times 12 and 5/10, if I check this on the calculator, it's 303. And then I have this number here, and I want to figure out what that is as a fraction.
I know.
How do I do it?
Oh, well, are you not going to do the fraction part?
Do you know
Wow.
fraction?
I do.
What is it?
Well, I would double. I would get 12 and a half plus 12 and a half. And that would give me, 25? And that would be a quarter. So a half of a quarter is an eighth.
Nice. Very nice. So 303 and 1/8. And you know what? When I'm working with the calculator, I want to do it twice. I want to see if I get the same answer twice. So it would be 24 and a fourth times 12 and a half. And I got the same number twice. And I could see if it makes sense. 24 times 12, yeah, that's at least 240. So I'm in the right ballpark. So I know I'm there. But if I were working at line on hand, if I didn't have an opportunity to use a calculator, and sometimes I don't, I can either do this math problem or I can do this problem. I'd probably vote for this one, but it'll work either way. All right, so I put that number back over here now. That's my big B. So this is inches squared. So 303 and 1/8 inches squared. And now I want to use the height. And this time it's the dimension I didn't use, which is that 20 inches over there. That's the height I didn't use. Since I'm using this space to do my area, it's how far is it stacked back that way in the 20 inches. So now I have to multiply those two numbers to get my cubic inches. And it's going to be a big number, but it's cubic inches. Usually when we talk about gallons, we're talking about gallons, which is related to cubic feet. So I would expect it to be a big number. So over here, if I do 303 and 1/8 times 20, I vote for fractions. I vote for decimals. I would do it as 303, change it to a decimal, and multiply it by 20. So 0 for everything. 0 times every number is 0. Placeholder of 0. 2 times 5 is 10. Carry my 1. 4 plus 1 more makes 5. 2, 6, 0, and 6 again. So I don't have to think too much here because I'm just adding it to 0. And I have 1, 2, 3 places. 1, 2, 3 places. So
Good job, Jason.
did it get the same number?
He did. And what we would have done, right? What I would have done was.
Oh, good. Stop me.
I'm just saying I would have doubled my, I'm just checking it, right? I would have doubled my 125 and 125, which would have given me a quarter, right? Like 2 times 125 and 125, because it's going to be, right, 25.
Okay.
And then I would have taken 2 times 603, which would have been 606. So 626. And, oh, is it 50 or 25?
Right? Or did I make a mistake? 3
No,
places.
maybe you're right and I'm wrong.
I'm going to double check it, I guess, on the calculator because that I can do that.
No, I think you're right.
6,062 and 5/10.
Oh, yeah.
And that's a really big number, and it makes me pause a little bit, but I'm multiplying a very big number.
Yeah.
20. So times 10, I would add a 0, right? And times 20, and double that. So it makes me feel that I'm close there. But that's a very big number. Remember, that's cubic inches, and we're normally thinking about gallons, which is equivalent to cubic feet. So we're closer related to cubic feet. Anyway, that's a rectangular prism, and that's a way to do it. And there was a lot of different math in there.
Jason, that's why we double check it. We always run it twice because that first answer was just off by a little, but a little's a lot.
Exactly. So it's a good time to always double check. And actually, the next problem I do, I can run it a couple different ways and check it a couple different ways. Go ahead and unmute. You guys are doing the guided practice today. That's page 430. Somebody unmute and let me know a number you want me to do. Something you haven't done yet, something that was tricky that you'd like to see. Give me a problem, I'll do it. Or which one, if you haven't looked at it yet, but you look at it now and go, boy, I really would like to have that one done for me.
Was this one on the page, Mrs. Brown?
No, this one was.
This is our one we did, right? Yeah. Okay.
Yes. But I'll take one on the page, or I'll pick the one I did before. I'd rather have one that you guys would want. Is anybody asking for anything there in the chat?
I don't see anything, and nobody's unmuting either.
No, I'm gonna pick for them. I'm gonna pick then.
Yeah, nobody's choosing. Everybody took a nap. Is everybody taking a nap except for Jason, who's talking to me in the chat? Here comes Euler. Jason already completed the page.
Jason, which one would you like me to double check for you by doing then?
Euler's asking for number 2.
Number 2?
Yep.
Well, number 2, I can do number 2. It's a little bit hard to draw in here. It's that cubic unit one again. So I can bring it really close here. So number 2 has to do with that cubic unit, and it says the volume of the large cube is how many cubic units. That's that crazy one where I have 4/5. I can do that one. So I'm going to draw a cube by drawing a square. I don't know why my marker's not, I'm probably not holding it right now. I am having marker challenges today. All right, I think that's good. All right, it's a cube, so they're only going to give you one dimension because all of the dimensions, all 3 dimensions are the same, and they call it 4/5 of a unit. Okay. Volume is always big base times height. And since my big base this time is a square, it's 4/5 of a unit. So we're just going to use 4/5 right now. 4/5 of a unit, if it's a square, I know that this must be 4/5. So big B is little base times height, or 4/5 times 4/5.
Oh my goodness. This is like that, this is like the explore activity.
Yes. So this is 16/25. I don't see any other way to simplify it. It looks simplified enough. And
Yeah.
that would be units to the second power. So they didn't tell me what units it was. I called it a unit. I'm going to put a unit here. So that's what my big B is. My big B I'm going to simplify as 16 and 25 units squared. My height is this dimension back here. So remember, not the face that I used for big B. It's my height back here. Since it's a cube, it's going to be the same dimension, still going to be.
And I love thinking about it. That's what's stacked in order to make it happen. So you have the 4/5 on the bottom, and now you need those others stacked on top to create it.
So now I'm going to do that over here. So it'll be 16/25 times 4/5, and that'll be units cubed. So 16 times 4. So if I think of 16 as 10 plus 6, 4 times 10 is 40. 4 times 6 is 4 times 6 is what?
24.
24. 24 and 40 is
64.
64. 25 times 5. That one I just know. I ran across that so many times. 125.
125. 5 quarters is $1.25.
And that's units cubed. And you know what? I can't even simplify that fraction. So that's the number.
I know that can't be simplified because there is no simplification within the problem. Like you couldn't simplify the 4 and the 25. You couldn't simplify the 6 and the 5. Everything was already prime.
I always want to look for simplification, but I couldn't do it. Incidentally, guys, any rectangle you think of for the face, for the base, is fine. And the other dimension you're not using is the one you use for H. So if you turn things around, it doesn't really matter to the problem. You can still do it. So I could use this face dimensions, and then that's my height. Or I could use this face dimensions for big B, and then that little bit's my height. I got a bigger area, but I've got a smaller height. Smaller area, but I've got a longer height. It really doesn't matter which face you choose, just whatever dimensions you're using for the face, the other one's your height. So it's either a small area and a big height, a big area and a little height. And since I'm multiplying, it doesn't matter.
Whichever units are easier is what I choose, but it's all different.
Exactly. There was a problem that I was looking at, and I was wondering if I had done this one, if I had chosen this face, my problem would have been easier. Maybe I would have gotten into this here that was really looking a little bit ugly. Sometimes you just want to think a minute before you get involved.
Jason, is that the answer that you got? Carissa, is that the answer that you got? Anybody out there? Hello?
If you've done it already, do you agree? We need to double check. So I need to explain my reasoning.
I think people went on a break. Did anybody else do the problem? Jason, are you there?
He's here.
Can you see him?
I can see him, yes.
Yeah, I can't see him.
Yes, it's just a screen. All right, are there any other ones I can do or any other questions we can answer? It's your time.
All right, well, that is the way to find volume of a rectangular prism.